Good afternoon, everyone. So, we'll be talking about dimensions today. Dimension analysis. Dimension is a very important concept in physics that you need to have a real background knowledge about. Dimension helps you to know the correctness of an equation. Now, we have M, L, T. These are the principal quantities that we use for dimension. Whenever a quantity is measured in kilogram, the dimension will be capital letter M. When it has to do with meter, the dimension will be capital letter L. When it has to do with seconds, the dimension will be capital letter T. Now, if you want to answer a question on dimension, the first thing you need to know is the correct SI unit of that particular quantity. Whenever you want to answer a question about dimension, you must know the SI unit. What do I mean by that? For example, if you are asked what is the dimension for velocity or speed, you must know the unit. Velocity or speed is measured in meter per second. That is unit for velocity or speed is measured in meter per second. Now, because the speed is measured in meter per second, the dimension is simply meter. Don't forget that meter is L. So that will be L. Seconds is capital letter T. So because you have minus 1, you just put your minus 1. So very simple. The dimension for speed of velocity is LT minus 1. What if I'm asked what is the dimension for density? Don't forget that I told you that before you can know dimension, you must be able to know the correct SI unit of that quantity. Now, even formulas can tell you the unit of something. Formula can help you out. Density is mass over volume, and mass is measured in kilogram. Anything volume is measured in meter cube. Mass, kilogram, volume, meter cube. So that means the SI unit for density is kilogram per meter cube. Kilogram, because of this division here, then we want to use the word per meter cube. So if you know that density is kilogram per meter cube, the correct SI unit, the dimension now, dimension for density, kilogram is M. Don't forget, whenever you see a unit of kilogram, dimension is M. Meters is L. Then you have minus 3. You put your minus 3. So that is how we get the dimension for density. If you ask that what is the dimension for force, for example, force is mass times acceleration. Normally, the SI unit for force is Newton, but the correct SI unit based from the formula is mass is kilogram, acceleration is meter per second squared. Why we just say force, the SI unit for force is Newton? It's just because of the scientist that was associated with the law of force has to do with Isaac Newton. So just to honor him, they just said, let the general SI unit for force be Newton. But from the formula, we can have the sub unit for force to be kilogram meter second square. So that it will help us in the dimension for force. Because I told you that dimension, we can only use kilogram, as has to do with meter, length, seconds, t. So from this now, I can know vividly that the dimension for force is simply your kilogram is M, meter, L, second has to do with t. So because you are having minus 2, you just put minus 2. So that is how you can say fourth dimension is mass L t, that is t minus 2 there from this. So I hope with this you'll be able to understand that whenever you are given the question about dimension, I've told you that the basic thing is that know the SI unit for that quantity. Once you know the SI unit for that quantity, you'll be able to answer questions pertaining to dimension. So at your leisure time, I would love you to try the dimension for pressure. You try that out. It's F all over A Newton per meter square. So break this Newton down, compare it with meter square, try it out, then you can send me your answers via the link. Thank you very much.